So let's talk about normal force versus weight versus mass. Because in Physics 20, this can get a little confusing just based on the definitions and understanding them. So the first thing I want to talk about is your weight, okay? And I'm not trying to be rude here. We're not going to talk about your weight in specific. We're going to talk about everybody's weight and what that means. Now, weight is the force due to gravity on an object with mass. So something weird about weight, it's actually just what the force of gravity is. So Fg equals mg. We've used this calculation before, but now sometimes we'll refer to it as weight. Okay, and now something to understand is you might see the notation W equals mg sometimes. But I would suggest sticking with Fg, force of gravity. Now, your mass is measured in kilograms, of course, and your gravity is usually, let's put usually, or on Earth, 9.81 meters per second squared. But this can change, which is really weird, because this is on Earth, and that's the funny thing about weight, is you weigh differently on Mars, because Mars has a different gravitational pull. And so when someone asks, what do you weigh? Well, it kind of depends on what planet you're on. It depends on even what part of the Earth you're on. Because if you're on a really giant mountain, you weigh less than somebody who's not on that mountain or lower. Because technically the gravity is less up there because you're further away from the center of the Earth. So the force of gravity is often referred to as the weight of an object, okay? And remember, an object's weight will change if they go live on the moon because the gravity will change. So that's always good to note. Now let's talk about mass. Now mass is actually what we usually refer to as weight in everyday English. But now that you're a physics nerd, when someone asks you what your weight is, again, what planet are we talking here? But if someone asks you what your mass is, well, that's actually what you should say. So my mass is around 72 kilograms. So that's Mr. Skaber's mass. And this isn't going to change, no matter what planet I'm on, because mass isn't affected by gravity. So mass does not change regardless of the planet you're on. The mass of an object is fixed. And of course, that changes depending on if you eat a bunch of food that day or maybe you didn't eat as much. It'll fluctuate a little bit, but we have an average mass. And the average mass is measured in kilograms. So that's weight and mass. Now let's talk about this weird thing called normal force. So hopefully you've watched a few other videos on the normal force, and this is just going to be a quick little review. But there are some things I want to mention that I feel are important. So the normal force is the force that acts perpendicular to the surface of an object sitting on it. So if I have a box that's sitting on a flat piece of surface, the normal force is directed perpendicularly to the surface. So that surface is pushing up on the box. If my box is sitting on an inclined plane, and that box sits on the inclined plane like this, let's draw a nice looking box here. Let's draw a nice looking box and then I draw that. Let's just make sure that it connects there. Okay, so now my box is sitting on this inclined plane here. Well, remember, the normal force is perpendicular to the surface it's sitting on. So there's my normal force. So hopefully you've watched a video that talks a little bit about that. But something to understand about the normal force is sometimes we refer to this as our apparent weight. Now, why would it be known as the apparent weight? Because this is kind of how we actually feel how heavy we are. Because if you think about it, if you take a 10 kilogram weight and you hold it, you technically feel heavier. Your legs are holding up more weight, and that means the ground itself is pushing harder on you because now you've added 10 kilograms to yourself. So your normal force actually grows as you put more weight on, or something pushes on top of you. So for objects resting on a flat surface, the force of gravity equals the normal force. Okay, and that's because there's no additional applied force. So here, if we have an object that's just sitting there, this object is applying a force on the ground. That's its force of gravity. But since this object is not moving up or down, we counteract that force with our normal force. And since the object is not moving, it has zero net force. And that's because the net force cancels out the force of gravity. So since these things are equal, it equals 0 newtons. So our box isn't moving. Now, if an object is sitting on a surface but has an applied force pushing down on it, the normal force will grow. Thus, your force of gravity does not equal the normal force. So if I do something like this, and I draw an object, but then I decide to apply a force on top of that object, so let's call it F applied here. So I'm pushing down on it, or maybe I set maybe I set some books on that box or something like that. Not only is my applied force pushing down on the surface, but so is the force of gravity. So in order for this object not to break through the surface, or in order for it not to move down, this normal force has to counteract that applied force. So it's going to feel heavier. So apparent weight of the box grows. And if we put ourselves kind of as if we were the box, if someone is pushing down on you, you technically feel heavier. So our apparent weight is growing because the normal force is growing. So here, your net force still equals 0 newtons because my box is not moving. Okay, your box is not moving. So here we would have 0 equaling the net force minus the force applied minus the force of gravity. And there you can see if you solve for net force here, it's actually the applied force plus the force of gravity. Thus our net force would be bigger than the force of gravity because we're adding that additional applied force to it. So again, the normal force is often referred to as apparent weight. It is known as the apparent weight because the normal force is the force that pushes against us, effectively making us feel heavier or lighter, and this depends on the situation. Maybe take a minute and think, when would we feel lighter? What would make our normal force feel smaller? I could think of maybe one. If someone tried to pick you up, but they couldn't pick you all the way up, they kind of get you onto your tippy toes, right? When you think about that, your body is still applying force to the ground, but it's not as heavy. So therefore, your normal force has gotten lighter. So take some time to grapple with these terms. And then once you feel like you're ready to see some examples, go click on the next video where we do some simple weight and normal force examples. Thanks.